Well, I think I finally found a way to make these videos high quality, the sound, the actual image, and so anyway, I'm going to go ahead and get started. As you can see here, 2.1 part 3, last part of 2.1, domain, difference quotient, and application problems. I'm just going to go ahead and get right into it. Finding the domain, first of all, we've done all kinds of domain problems. When you look at this first problem here on the left-hand side, we see that we have a denominator. So the things I identify here, we've got a denominator. We know that denominators are not allowed to be 0. So let's just identify that right away. And then we have one more issue with the denominator, and that is that underneath the radical, we know that underneath the radical, that has to be greater than or equal to 0. Okay, so let's take this one here. Let's take this, what am I trying to say? Condition. So here's a condition. So the condition being that x has to be greater than or equal to 4. And so right now we have a temporary domain that x has to be greater than or equal to 4. But if you notice right up here, if we did use 4, so if x were in fact equal to 4, that would make the denominator 0. So therefore the domain would be all real numbers x, such that x has to be greater than 4. Okay, so x equaling 4 would be a bad thing because it would make the denominator 0. So anyway, there's the domain. Over here in the second problem here, we see that we have still a denominator, and so our denominator, we know that is not allowed to equal 0. So in other words, z is not allowed to equal 2. But we have this other stipulation that z plus 3 has to be greater than or equal to 0. So we have the condition that z has to be greater than or equal to -3. So when we add subtract 3 from both sides, we see that z must be greater than or equal to -3, but z is not allowed to be equal to 2. So we see the domain would be, let me do it on a number line here. Let me try to find a different color. So if we show this on a number line, it's a little bit more clear. Here we have -3. If we did draw the picture on the number line, don't forget we have 2 here, and we're not allowed for z to be equal to 2, but z can be anything else. Okay? So basically that's our picture of our domain, and how would we write that? The best way I think to write that would be, the domain would be all real numbers from -3 to 2 combined with the interval, or combined with the interval of real numbers that are greater than 2. And that's how you would write that. Okay? So there we go for the domain. So some of these problems that, like today, are part 3, you're seeing problems that are a little bit more challenging, and nevertheless, I think you guys can do that. And then I have a pause problem for you. So you're going to have problems that I show you, and then there's going to be problems that I say, okay, go ahead and pause the video and do these. So here's your pause one. And go ahead and pause the video, and I'll actually show you the solution. So 3t minus 21 has to be non-negative, or sorry, it can't even be 0. Can't be 0. So if we add 21 to both sides, we see that 3t is not allowed to equal 21, and then dividing both sides by 3, we would see that t is not allowed to equal 7. Okay, but then there's another condition that must be met. The other condition is that t minus 4, right here, t minus 4 must be non-negative, and so if we add 4 to both sides, we get that t has to be greater than or equal to 4. So we have these two conditions, and when we put these together, it all has to make sense. And so if we look at these on the number line, I think it's a little bit easier. Greater than or equal to 4 goes this way. But remember, 7's over here, and t is not allowed to equal 7. So there we have our interval of real numbers that indicate our domain. So we have the interval from 4, including 4, all the way to 7, but not including 7, combined with the interval from 7 to infinity. In other words, all real numbers greater than 7. as well as all real numbers between 4 and 7, including 4. Okay, so that's the find the domain question. Now we go back to find our difference quotient. Okay, so here are the two difference quotient questions, and I know we've done these, but I keep getting questions on these, so I'm going to go ahead and do a couple more. F of x is given to us, and you know what, I just got, I'm going to stop the video